Okay, so after we do this one, I might do a couple of the other ones on the homework, the ones that have the license to integrate, just so we make sure that we're all clear. Or the ones that don't have the license to integrate, where we have to come up with our constant, because I think those are the ones that are more confusing. These are ones that do not have a license to integrate, and you cannot create one, because there's no way to get a constant that you can pull to the front. And that's in this case because of the 2x plus 1 on top. So because of that, we have to use u substitution. So the first step is let u be the inner function. We talked about that yesterday. When they say inner function, they mean the inner function. It's going to be inside of something else. So in this case, it's u equals x plus 4. So the second step is to find du and solve the equation. So the derivative of u, that's du, equals whatever you take the derivative of the x side. Well, in this case, du happens to equal dx, because the derivative of x is just 1, so it would be 1 dx. Okay, so then, this is where we left off. Find an expression for x in terms of u. Well, we have right here, u equals x plus 4, so I need to just solve it for x. So I subtract 4. So that's where I got x equals u minus 4. Okay, so now, everybody's good so far? Okay. So now rewrite the entire integrand as a polynomial or a polynomial type of function in terms of u, then we can take the antiderivative. So I'm rewriting my function. Now, at this point, I am just rewriting it to move the square root up. I'm going to put a -1/2 on it. So I'm not changing anything yet. I'm not subbing anything yet. Okay, so real quick, let me make sure it shows. So all I was doing, this is just a rewrite of this. I've not subbed anything. I just wanted to move my square root, make it more of a polynomial type function. It can't be a polynomial function, by the way, just for matter of reminder. If it has an exponent that is a rational exponent or a fraction, it's technically not a polynomial. That's why the instruction says a polynomial type function. Because we can still take the antiderivative as if it were a polynomial function, if I do that too. Okay, so I did that first. Now I am going to substitute. So I'm still going to leave my integrand because I'm just subbing in for u. I'm subbing in for x, I'm sorry. So 2 times u minus 4. In my head I just replaced it the backwards way. Plus 1. That's this piece. I'm going to put it in brackets. And then that's going to be times... Okay, now if you look at this, this is x plus 4. This is x plus 4. So I'm going to write this as u to the -1/2. And dx is the same thing as du, so I can just replace it. Okay, so now I'm still leaving my integrand sign because I'm just going to simplify. I'm going to distribute the 2. So I get 2u minus 8 plus 1, so it'd be 2u minus 7 times u to the -1/2 du. Now I'm going to distribute the u to the -1/2 so that it's going to be a polynomial type function. So I'm still leaving my integrand. Okay, when you multiply, what do you do with exponents? Add them. So currently there's a 1 on this u plus -1/2. So it's going to be 2u to the 1/2 minus 7u to the -1/2 du. Okay, all of that was just simplifying so that I can take the antiderivative. So now let's take the antiderivative. So this will be 2u to the 3/2. I'm going to go ahead and write it as divided by 3/2, especially for those who are not here and are watching the video, so I don't lose anybody in the process. Minus 7u to the 1/2 divided by 1/2 plus c, because I just took the antiderivative. So if you remember, when you take an antiderivative, you add 1 to the exponent and then divide by that new exponent. So I added 1 to 1/2. That's where I got 1.5 or 3/2. I added 1 to -1/2. That's where I got 1/2. And then you divide by your new exponent. Okay, so now I'm going to keep switch flip and simplify this. I'm going to write it kind of smaller because I think I'm running out of room here. So that would be 2/3 times 2u to the 3 halves minus 2/1 times 7u to the 1 half plus c. So 4/3 u to the 3 halves minus 14 u to the 1 half plus c. And now all I have to do is plug my u back in. U was x plus 4. And that is it. Okay, so now that on these first two that we did, the one that we did yesterday, and then this one, they gave us the steps. So on the next one, they do not give us the steps, so we're going to have to follow the steps on our own. So on this particular one, do I have a license to integrate?
No.
No. If I did, what would it be?
2.
2. And it's not a 2, it's an x. And since it's an x, there is no way for me to get that with a constant, because x is a variable. So I have to do this by u substitution. So my first step is to identify the inner function. We'll call that u. So u equals 2x plus 1. I'm warning you now, write small. Okay, so find du. So du equals 2 dx. So I took the derivative of the u side, that's where du comes from, and I take the derivative of the 2x plus 1 side, so that's 2 dx. Alright, so now we have to solve that for dx, because we're going to replace. So I'm going to divide both sides by 2, which means dx equals, I'm going to write it as 1/2 du. That way when we rewrite our integral, it looks correct. Alright, so now we have to find an expression for x. So now we're going to find an expression for x in terms of u. So I'm just going to take my u thing here and solve for x instead. So that's going to be u minus 1 divided by 2. Okay, so I'm going to so now because we did u substitution, we're going to have to fix our interval values, because our interval values are written in terms of x. We are going to have to write our interval values in terms of u, because we are going to rewrite our entire integrand in terms of u. So it's super easy. All you have to do, I have u equals 2x plus 1, so I can change all of my x values into u values just by plugging them in. So my first value on that's listed as my interval is 0. So I'm going to do 2 times 0 plus 1. So u equals 1. So that is going to be my lower bound when I rewrite this in terms of u. Got to do the same thing for the upper interval, so that's going to be 2 times 4 plus 1. So u equals 9. So when I rewrite this, instead of going 0 to 4, I would be going 0 to 4 if it was an x, but since it's in u, I'm going 1 to 9. Is everybody okay? That's the first time we've had to do that, because if you look back on the rest of the page, they haven't given us any intervals. We have just been actually finding the antiderivative and not actually calculating with intervals. So this time, that's the first time we've had this subpart intervals. Alright, so now I'm going to rewrite this. So my x I'm going to rewrite as u minus 1 divided by 2. Because we want a polynomial function, is everybody okay if I rewrite that as 1/2 u minus 1? Because I want a polynomial function in a minute, so that'll help me. Alright, so I had 2x plus 1. It's the square root of 2x plus 1. And here's 2x plus 1. So how am I going to write that in terms of u? Square root of u, but I need it as a polynomial function. U to the 1/2. Now, if you wrote it as square root of u, that's fine. You can just use more than one step. It's okay. Doesn't matter. And then now I need to replace. So I replaced x with this. And that came from here. I just rewrote it because I'm looking for a polynomial function. Of course I don't have a so then I just now rewrote this as this. Everybody good? So I have one more thing I need to rewrite in terms of u, and that's this piece, dx. Well, I know that dx equals 1/2 du. So that's what I put right here at the end. Everybody good? So we really did. It literally is substitution. You substitute in every piece. Okay, so now let's simplify this. I have a 1/2 and a 1/2. That's a fourth, and they're both constants. So we can move them to in front of the integrand. So I'm going to do 1/4 in my integrand. I'm still simplifying, so we haven't taken an integral yet. So that leaves me u minus 1 times u to the 1/2 du. Now I'm going to distribute this. Still simplifying, so I haven't taken my antiderivative yet. So that gives me u to the 3/2 minus u to the 1/2 du. Alright, so now let's take the antiderivative. I'm going to put the 1/4 in front still, because it's in front of the sign, so it's a constant in front of the whole thing. Now I'm going to take the antiderivative. You add 1 to the exponent and divide by that. So that's going to be u to the 5/2 divided by 5/2 minus u to the 3/2 divided by 3/2. So far, so good? Okay, I'm still simplifying, so here's my keep switch flip. The 1/4 stays in the front. This is now 2/5 u to the 5/2 minus 2/3 u to the 3/2. So far, so good? Yes. Now plugging in 9, then plugging in 1. Okay, 1/4 goes in front of the whole thing. So 1/4, 2/5 9 to the 5/2 minus 2/3 9 to the 3/2 minus. Okay, I'm going to write out this next step. Where did I lose it?
Okay, it's du. Wait, no.
I might have done something wrong.
Hold on. If we got it down to there, wouldn't we have to plug in the x and then plug in the 9 and the 1? Cause those are X values, yes or no?
Those are U values now. Remember, that's why we did this?
Okay, yeah, I went off on a tangent earlier by myself trying to do it and I erased everything, so.
So that's why we did that, so we wouldn't have to plug in X and then find U.
Okay.
So, okay, so now I'm going to simplify this. Now, if there's a 2 in the denominator of an exponent, what does that mean you're actually doing? Square root. So I can take the square root of 9 and then raise it to the 5th power. Now, I'm going to write that step out just so we don't lose anybody. So I've got 2/5, and if I take the square root of 9, that's 3 now raised to the 5th power. Now this second fraction's easy because it's a 1 though, so we like that, because that's just going to leave me 2/5 and 2/3. Okay, I'm going to be honest. Off the top of my head, I do not know what 3 to the 5th is. I can figure it out, but I'm gonna do the ones I do know first, because I know this one. 3 to the 3rd is 27. So if I made this 27, and 3 goes into 27 9 times, I now have minus 18. And I'm going to distribute my negative. Minus 2/5, minus 2/3.
Wouldn't it be plus 2/3?
Oh, yes, it would be, thank you. Plus 2/3. Okay, let's see. 3 to the 4th is 81. Times 3 is 243. Yeah, 243. So 1/4, 2 times 243. 5 doesn't go into that evenly, so that's nasty. Okay, well it does say check your results using your graphing calculator, and since it says that, let's go ahead and plug this much into our calculator, and then we will actually check the entire antiderivative. So, hold on. It's going to be either a nasty fraction or a nasty decimal. I can tell that. So let's see, 1/4.
It's a lot later every day outside. And then he said,
Okay, so this is what I got as a fraction. I got 298/15, which as a decimal approximation is 19.867, because it's 0.866666666, so 0.867. Okay, so now what we want to do, because it said check it with your graphing calculator. Obviously, I just got that answer from my calculator, but I want to go back and check this from the very beginning with my calculator and see if that's what we would get. Oh, yep. Yay, it's all right. Okay, all right, so let's look at, here's the homework assignment that goes with this page. And let's look at a couple of the ones, like the ones yesterday, where we have to get rid of our constant, or find a constant to get rid of our constant so we can have the right license to integrate. I think the ones at the top, let's just check the ones at the top and see which ones already have the correct license to integrate. And then if they don't, we'll do one. Okay, so, well, number one doesn't, does it?
Yeah, no.
Because what would the license to integrate be?
4x to the third.
4x to the third, and it has x to the third. It doesn't have 4x to the third.
So we can.
And it would need it. So what I would need, and this is where I knew it was confusing. So I need it to look like this. But it doesn't, right? So why doesn't it? Or what could I do?
Couldn't we just put a 4 in front of it instead of 1/4?
Yes, exactly. So in order for it to look like this, I would have to do 1/4.
No, not the white screen of death.
Uh-oh. This is what, I just wanted to make sure that everybody's clear on exactly why we're doing what we're doing. Because this, what I just wrote, if I'll put my hand in there, you can't see it. What I just wrote, 1/4 with the 4x in there, this 4 and that 4 cancel. So really, this and this are the same thing. So I really didn't change anything, but I just gave myself the license to integrate. If that makes sense. I'm trying to make sure we're clear on why we write it that way. Because I know we were getting some of our fractions and stuff upside down. Okay, so you can continue and integrate that one if you want. Let's do another one. Let me see if I've got one that's got a, yeah, let's look at number 5, I think. 5's a good one. Okay, what would I need, in order to have a license to integrate, what would I need?
2x.
I need not 2x, but negative 2x. Because you're, so I need it to look,
So you just put -5 halves up front.
so if I put negative, I'm going to write this as to the 1/2. Then these two things are equal. Because the 2 would cancel, the 2 negatives make it positive, and it becomes a 5x, which is this. So these two things are equivalent. So you really didn't change anything, you just provided yourself a license to integrate. Alright, so I was just making sure everybody's okay on this. Okay, so you should be good.